So what's up, guys? Let's continue with the next component. So we have been building an end-to-end machine learning a model that can be used to predict electricity bills. So we started with the data ingestion, data validation. Now we are at the data transformation stage. Okay, so we are going to start with the data transformation. So if you haven't watched the previous things, 2 or 3 videos, you can also find time to watch them so that you gain a better context of what we are doing. So this is the data transformation stage. So we are going to see how we can do data transformation before we train our model. Okay, so when we are building the model itself, so you can see here that our data contains we have floats, we have integers. So when it comes to data transformation, then we do need to convert these categorical values we convert them to numeric, or we substitute them with numeric values, convert them to numeric values. And in our model, we did that using the one-hot encoding. So the same thing that we did when we were building the model, we're going to repeat the same thing under the data transformation. So one of the things that we will be doing is the one-hot encoding to try to convert those categorical values to numeric values, because our machine learning algorithms, they do accept numeric input. Also, another thing that we will be doing is the standard scalar. As you can see, before training our model, we scaled our data. Also, that's another thing that we will be doing in addition to other things, let's say imputing and all that. So all those things will be happening under the data transformation. And also we'll also be doing a train test split under the data transformation. We also obtain some artifacts, the training data, the testing data, okay, transformation of those. So those are some of the artifacts that we will be obtaining under the data transformation. So stick around as you stick around, and you will see how we are going to perform those operations. Okay, so before we get started again, please consider subscribing, hit that notification bell so that you never miss any of our video updates. You can also like this video and comment. We'll try to get comment if you have any query about any question, and we'll try to get back at you. Okay, so let's get started. So we're going to start with the data trans. So I'm going to create another folder under the research. So this is just the experimentation section. So we do the experimentation like a prototyping. Then from there we can convert our code into the modular coding structure. So this is the part 3, where we will be dealing with the data transformation. So data transformation.py. So with the data transformation, so we start as usual by importing the necessary libraries. So I'm going to import OS. So again, I'll import pandas. So import pandas as PD. Import numpy as np. We'll also import joblib. Import joblib, import path, pathlib, import path. So this one is will be from pathlib. Okay, so from pathlib imports path. We're also going to import the data class. So from data classes, import data class. Also, we are going to import the logging. So from src, so dot electricity bill dot this one cc bill. So import logging. So we're also going to import, so in terms of utils and everything, commons, we are going to import save objects. So there are objects we are going to save. Objects. So we're also going to import from the scikit-learn library. The scikit-learn library. So I'm trying to group these libraries together. We are going to import the 10-test split. We're also going to import the column transformer, pipeline, simple imputer, and the standard scaler, as well as the one-hot encoder. Save objects. So data transformation. Save objects. So we also need to import the schema and all those things. We are going to import constant config path, params, schema, YAML, create directories. Okay. Data transformation configure. Okay. So let's start with the data class. So up to here, the first things are just common things that we have been doing. So we are going to data class. So at data class. So for the class, we are going to form a class for data transformation. So data transformation config. So here, data transformation config will be the class that will be holding. Will be the class that will be holding our the necessary file paths and everything. So when we talk about the file paths and when you talk about file paths, we go to the config.yaml. Under the config.yaml, we are going to define these necessary paths. So this will be the data transformation. So let's define the paths. So data transformation. Under data transformation, so root directory. So our root directory will be artifacts. It will be artifacts data transformation. And then the data path. So we need to define some data paths. So data path artifacts data ingestion electricity bill.csv. So that's the data path. Then we do have, remember, we do have numeric and categorical columns. So numeric columns. So in the data transformation, we are going to do some we are going to split all these columns, numeric columns. So the numeric columns, so we are going to specify those. So under the numeric columns, there's one thing that I need to specify here, is that when specifying these numeric columns, we are going to refer all those columns except one column, and that is the electricity bill column. It won't be, we won't list that column at the moment. And the categorical columns, So these ones we are going to specify. This is the city and company categorical columns. So city, company, these are the categorical columns: traffic rate, monthly, month, motor pump, monitor, television, air conditioner, refrigerator. Those are the numeric columns. So you'll see why we are trying to separate these columns into numeric and the categorical columns. Okay, so you just see that. So under this, we need to specify those paths. So root directory, that is the path. Then our data path. Again, this will be something like a path. Then the numerical columns. This one will be something, it will provide something like a list. Then categorical columns. This again will be something like a list. So you need to make sure that we don't need this. Data validation, don't need this. Main.py, we don't need this. Electricity bill prediction, again, we don't need this at the moment. So data transformation, we need this. Config, so you just make sure that the categorical columns, so that you are not getting some errors. So you need to make sure that the spellings and everything is okay. So just to confirm numeric columns, just to be sure, need to avoid unnecessary errors. So data class, data transformation config. So we have specified that. After this, you're going to create a configuration manager. So class for the config manager. So the class for the configuration manager. So we are going to create this. So for the configuration manager, remember this is just the same thing. We're not trying to change anything. So if you go to your data validation, our configuration manager is just the same thing. We're not trying to change. This is the configuration manager. So we're just going to copy this. So there's no need of typing that information again. Okay. So class configuration manager. Here we list the file paths and the schema, everything. So we updated our schema. In data transformation, we don't have a schema, so we won't be dealing with that. Then after this, we need to get the data transformation config. So I'm going to get the data def get transformation get. Okay, these things just come like this because I've used them more and common. I've used them often, so I think it's just using my past coding structure to just bring these things forth. So for the config, self.config data transformation, that's okay. Then after here, we create our directories. So we create we need to create the directories. So create directories. Yeah, create directories. Then we can say config root directory root dir. Yeah, that's okay. Then after this, we need to now create and return the data transformation config object. So create and return the data transformation config object, data transformation config. Whatever we are listing here, it's just the same things that we list under the data transformation config. So that's just the same thing. Okay, then we are going to return the data transformation config. So those are just the common stuff. So I think up to now you fully understand these things. So there's no need to explain over and over again. So after this, the next step is about creating a class to handle the actual data transformation process. So here we're going to do several things. So I'm going to create the first class. So nope, no, don't need this. We need to create a class. So class data transformation. So this class is going to handle the, now this is the supposed to be trans. We are going to handle the actual instructions that we have provided. So def init, then I can just do away with this. Here. And self, that's okay. You can just do away with this. Then we can say self.config, self.config, then config. So I think that's self.config. No, there's something we are not adding here. Need to add the configure data transformation config. Yeah, this one. So self config. So with this, can document, can explain. So look at so we needs to complete. Anyway, no problem. So config. So after this, we need to start actually with the coding part itself. So let's start with the so def get the transformer object, transformer obj self. So here we are going to try to do some manipulation data transformation steps. So just do the pass first, then accept as supposed to be exception as e, accept exception as e. So that's accept exception as e, then you raise e. That's okay. So the pass. So let's start now. We need now, remember we did separate our columns into the numeric columns as well as the categorical column. So let's call that here. So separate the numeric and categorical, because when it comes to data preprocessing, they will require different preprocessing steps. Okay, that's why we need to separate them. Then after this, we are going to create a pipeline for numeric columns. Because numeric columns will have different type of data preprocessing. Because, for example, for the numeric columns, we don't need to apply the one-hot encoding. Okay, so that means it will be different from that of the categorical columns, which require the one-hot encoding. For the numeric columns, either we can just apply the simple imputer, as you can see, the standard scalar, and any other thing. Okay, so for the simple imputer, we imported the simple imputer. This one here, simple imputer. So we are going to use that, the simple imputer. So simple imputer, if our the columns are containing missing values, then we're just going to use the simple imputer, and the strategy to fill those empty values in the respective columns will be the median. So it will calculate the median value in the specific column and fill those empty spaces. So numeric transformer pipeline, and then we can state the steps. The steps start with the simple imputer. Then after you're done with that, go to the standard scalar, and that's it. So that's for the numeric transformer. So after this, we go to also create a pipeline for the categorical columns. So I like this one being here. Then just to create some separation. Just add an indent here. Okay. So then we can need to create a pipeline for the categorical columns. That's okay. Then again, categorical columns transformer pipeline. Then the steps, that is the imputer step again. Strategy, we are going to use let's use the most frequent. Then field value missing, that's okay. Then for the one hot, after that we should do the one hot encoding, then handle ignore. So that's it. So that's the categorical transformer, and this is the numeric transformer. So that's why you are trying to do that separation. Okay. So the separation, it has really helped us to handle the columns separately depending on their data types. Okay. Then after that, we can then merge these columns together, do something like a concatenation. So combine the numeric and the categorical pipelines together. So here we'll need a preprocessor. So we create a variable preprocessor, and then we call that column transformer. So remember, we initialized our column transformer. This is the column transformer. So we imported that. So after importing the column transformer, this is the column transformers. Then the numeric, then you say, okay, no problem. Numerical, let's say numerical. And this one, we can say categorical. So numeric, then numeric transformer, numericals, categorical transformer. So for the numeric columns, we are going to call the numeric transformer. Then this is the numeric transformer. Then you are telling our code, we have listed some steps in the numeric transformer. Please ensure that you follow those steps while doing the data transformation. Then for the categorical columns, again, we have listed some steps. That is the imputer and the one hot encoder. Follow the same steps. Okay. Then after you're done with that, you're going to combine this. Then there is one thing that we need to, for example, let's say you have columns that you're dealing with the date time information. So as you can see here, we have not listed any columns that has we are not working with data that contains date information or date or time, something like that. It's only integers, or for example, integer or a float, or object which is just something like a string. So if you do have columns that do contain a date, or for example, you have stated that I don't want you to touch these columns. Okay, so the remainder, that's what the remainder, this remainder comes through. It will form our transformer object that you don't necessarily need to interfere with these columns. So just pass through all those columns that we have left them. We have not defined them in any way or shape or form. Then after this, we are going to return the preprocessor object. So we are going to return the preprocessor. So the reason as why we are returning this preprocessor, we are going to be using this preprocessor after we have split our data into the training set and the testing set. Because remember, in the scaler, for example, there's a way you scale your training set, and there's a way you scale your testing set. So you will see how we are going to apply this preprocessor to our training set and the testing set. Okay, so that's all about getting the preprocessor object. So after we have defined that, we need to do another thing, and this is about doing the train test splitting. So we are going to split the data into training and testing sets. So so here I'll just say train test splitting. Let's call the function train test splitting. So we are going to split our data. So let's say self. So we are going to split our data. So again, I'm going to try block pass. Then we can say except exception exception as E. Then we need to raise Press E. That's okay. So under this we need I'll use a logging.info. So we can log a message to say we're going to log a message to say something. So let's say data splitting process has started. So started. Yeah. So it's supposed to be logging the double G. So logging. So the process has started. So I'm going to call my data. So df pd dot. I'm going to read the CSV file. Underscore CSV. Read CSV. Then we are going to read the data. So self dot config dot now the data path. So it's going to read the data from the data path. So our data path, when you go to our config, then the config.yaml, we have specified that our data path is in this section or this folder. So it's just going to read this, then it will guide it will guide that to the data ingestion, artifacts, data ingestion, electricity bill, dataset.csv. So it's going to pick that data from there. So that's this line of code that it's going to be doing. Then we're going to split our data into the independent and the dependent features. So we are going to drop. So here I'll just specify columns. Then now we are going to drop the electricity bill column. So we are going to drop that. So we can just say this and that. Okay, so df.drop columns electricity bill column. Then our y will just contain the electricity bill column. Then after this, we can use another logging.info. Here you can say splitting data into training and testing set. Training and testing sets. So splitting data into the training and the testing set. So let's see. So x train, y train, the same thing. So splitting your data into x train, x test, y train, y test, train test split. Remember this, x and y. Test size 0.2, random state 42, no problem. So this is okay. You can use 142, 127. It all depends with what we are using. Then we can also do some logging information. Then we can say logging. So logging.info. Then we can, after splitting our data, we can save the training and the testing sets artifacts. So we are going to saving the training and testing data in artifacts folder. So save, can say save the target variable. So I'm going to save the target variable for both training and testing. Okay, so you can say y train dot to underscore csv os dot path dot join os dot path dot join buckets self dot path dot join self dot config dot root directory dot config dot the root directory. So root directory, and we're going to save this as y train.csv. Then we need to say that we don't want the index. Okay, so this is the training set. This is supposed to be false. False. So the same thing, we're going to do the same thing for the y test. So y test to csv os.path.join. Okay, so you might wonder as to why. Okay, let's just add them before I can explain. So we have the training data. So you can say xtrain. Okay, so save the target variables for both training and the testing set. So you can see the y train and the y test. So after doing our split, we have the xtrain, xtest, xtrain for training, xtest for testing. Okay, so we are saving the y train and the y test. So these are the target variables for both training and the testing set. And here we can also save the training training set, the training set data for both training and the testing set. But I won't be returning this simply because we are going to do some transformation on the training data as well as the testing data. So I don't want to save them yet, okay? Because if I save them, then I need to again import them, which is quite laborious. I don't want to do that. Then what I'll just do is add some logging information. So logging, splitting the data process has completed. Then we can do return. We can return. So I'm going to return the xtrain, xtest, ytrain, and ytest. So I'm going to return all this. But remember, if I'm returning this, I'm not saving those data frames for the xtrain and the xtest, because we are going to do some data transformation using the preprocessor. So there's no need of saving those yet, like at the moment. So we will save those after we have done the transformation. Okay, so this is about the training test splitting. Now we are going to initiate the data transformation. So we are going to initiate the data transformation. So you can just say initiate data transformation. So instead of self, again, we are going to say, we are going to call, so whatever we are returning in our previous method, we are going to use that as parameters in the next method. So here, now this method is where we are going to do the actual data transformation. So again, I'm going to say try. So login info data transformation. You can just solve this problem. So logging info data transformation process has started. Then we are going to get the transformation object that we created earlier. So that's what we are going to do here first. So after we get the transformation object, so that's the preprocessor object, self.get transformer object. So this one here, transformer object, the preprocessor here, self.get transformer object. So once we get that, we need to transform the training and the testing data. Transform the training and the testing set data. So transform the training and the testing set data. So those are now the xtrain and the xtest. So we can say xtrain transformed, and then the xtest transformed. So xtrain transformed and xtest transformed. Okay, xtrain transformed, xtest transformed. So in the training set, we are fitting, then transforming, but in the xtest, the training set, we are only doing the transforming only. So you need to know that. Then after this, we need to save the preprocessing object. So save the preprocessing objects. So we need to say the preprocessor path, save, can say save objects, something like this, save objects. No, we need to use joblib, or we can say preprocessor obj object dot joblib. I like joblib because if we are creating a sparse matrix, and joblib is quite efficient in ensuring that even though we are creating a sparse matrix, we are trying to create a sparse matrix with a that is small in terms of size. Okay, so save objects. Remember, we called a function here, save objects. Okay, so that's what we are using here. So preprocessor dot this, save objects, preprocessor dot this. So that's okay. Let me try something. Okay. So preprocessor object, os.path.config root. This one then self.config. So after this, we can do another thing, that is now save the transformed data path as arrays or sparse matrix under the .joblib format. Okay, so we can save those now this as array object. So xtrain transformed path. You can just say as and say sparse matrix. So xtrain transformed path. This will be os dot path dot join, then self dot config dot root directory. Then here we are going to call xtrain transformed dot joblib. Xtrain transformed dot joblib. Then it's supposed to be in quotation marks. Xtrain transformed dot joblib. So that's for the training. For the X test, again, it's just the same thing. X test transformed path os.path.join to self.config root directory X test transformed.joblib. Then we can say joblib.dump. So joblib so it needs to dump these files. Xtrain transformed in the xtrain transformed path, and also joblib.dump xtest transformed in the xtest transformed path. Then we can also include some logging message, info data transformation process complete. Then we need to return something. So we can return return the xtrain transformed, xtest transformed, ytest. You can also return the preprocessor path. We need to save this into some preprocessor path. So preprocessor path. Let's say os.path.join. So this is the self.config root directory. Then you can call this the preprocessor joblib. Save objects preprocessor. Then we can save this as an object. Supposed to be save objects. Let me confirm something. Preprocessor objects. So this one is supposed to be preprocessor obj object. then the preprocessor underscore object, so it's obj. So that's okay. Then there's something. I think save objects. Why are we not calling that save objects? That's okay. Then we need to call our preprocessor path. There's something you're missing. That's why we are getting this error. Exception. Oh, this one. Having this one, yeah. So that's the data transformation. So after, then we can then to the pipeline. So for our pipeline, we can so if underscore name underscore then underscore main underscore then what you can say about this is try block. No, we don't need this one at the moment. Okay. So config, we first initialize the configuration manager. So config configuration manager. By initializing that, we get the data transformation parameters. So data transformation config, data config.get transformation config. Then after this, we need to initialize the data transformation class, data transformation, that's okay. Data transformation, config, data underscore transformation config, that's okay. Then after that, we need to get the splitting the data, xtrain, xtest, we split our data transformation, okay, that's okay. Then after this, we perform the data transformation, xtrain transformed, xtest transformed, ytrain, perform data, no, xtrain test, ytrain splitting. After we have done the splitting, we can perform data transformation. So we can, what we can do, we can do this, say train a data path, test data path, test data path, or we can just say test data path, train test path, ytrain data path. I'm going to say y test, no, you can just say ytrain data, y test data, ytrain data, y test data, then the preprocessor path, and then you can just do the data transformation, then dot initiate data transformation. Then here we can pass in the argument, which is the x train, x test, y train, and then y test. So let's try to do this. Try to correct this syntax. Let me try something. And just add that path right in that path y test data path. So preprocessor path hyphen, then you can add this data so the one thing that I want is to use this is the forward slash. Forward slash, I think it's now okay. I think if name underscore main. So I just wanted to use this slash so that we can slash this code is quite lengthy, so it can fit. I think with this we are okay. So let's try to, we have the main, so let's execute this. So new terminal, the new terminal, what we are going to, so Python, then data transformation, copy relative path, paste it here, make sure you have saved your code, then execute. So we need to get an artifacts folder, and this artifacts folder, we need to see the xtest and the ytest, the xtrain.joblib and the ytest.joblib, something like that. So import there save name save job commons. Yeah, I think in the commons, so that is the utils. You can go to the utils commons. We have save object, not save objects. Yeah. So it's supposed to be save where. So just change in the data transformation. So you can just change save, instead of save object supposed to be save object, then at this point just change this to save objects. So we can save this, then Control C, we can then execute this. That was just a slight error. Save objects, cannot import the name save objects. Yeah. So let's see if you're going to get something from this. So the data ingestion and the data transformation, they are quite intense, resource heavy, because they involve a lot of, okay, you're getting an error. So repeat error, non-type object. So splitting data started, data transformation to this. So we are getting an error. Data xnxts data transformation to 10 test splitting. So this is in the line number 176, 170. Let me just cross check. So initiate transformation, preprocessor object, self.get transformer object, xn transformed, fit transform x-ray, x-test, preprocessor object, pd.read, self.config data path, data path, self.config data path. Data path. One, two, three, four. Okay. It's supposed to be four list path. Okay. So again, indentation error. This one here. Get data transformation. Then why is this not responding? There's some issue here. So get def is supposed to be the same, and this one should be get root directory. So get, let's see, think I was not returning the data transformation config, if I'm not wrong. Let's see if the error is now resolved. So you need to be very careful with your code to just avoid these small issues. The problem is that even a single comma is going to bring you some huge challenges. So you need to be very careful with that. Yeah, everything is okay. Now you can see now our data transformation is working okay. You can see created the directory artifacts, created the directory this. Data splitting process has started, splitting the data into training and testing set, saving the training, okay. Data splitting transformation process has started, data transformation process has completed. So we had an issue with this. We were not now, after creating the data transformation config, we were not returning the transformation config object. We are not returning that. So that's why it was not. So when we come to this section here, data transformation, I think return data transformation, I think this one. So it was not going, it was not finding it. Okay, that's why it was printing that error. But up to now, you can see everything is okay. You can go to the artifact section. So in the artifacts, you can see this is the data validation. I show you it is true. So data transformation, you can see we have the xtrain and the xtest. We have the training transformed data. We have the testing transformed data. And also we have the preprocessor object. So preprocessor object will be used. So the reason as to why we have saved the preprocessor object is because after the user has input data, so we'll build an app, something like that. So the user will enter the data. So that data has to come to the preprocessor object. So the preprocessor object has to process that data. Then from the preprocessor object, that data now comes through the prediction pipeline, where we get the prediction based on the user input. That is why we are using the preprocessor object. So for training our model, we need our xtrain that is preprocessed. We also need the training set that is preprocessed. We did not preprocess the ytrain or the ytest. So those will be used as the way they are in the CSV form. So we'll just import them as the CSV form. So it did not require a lot of transformation, okay? So after this, we need to convert our code into modular coding. So as usual, we are going to start with the entity. I'm going to close what is unnecessary. So data validation config, this one is okay. That's okay. Then we need to possibly, start with the entity. So entity configuration entity. So in the configuration entity, we are going to copy this, the data class, this configuration entity. So this entity, this is for data, not validation, data transformation entity, data transformation entity. So we copy that, we save, then we can close this. So make sure you have saved and close this. So after the entity, we need to go to the configuration manager. Configuration manager, so that is the config, config.py. So get data validation config. So here we are going to get data transformation config. Okay? So this one is the only thing that we're going to copy here. So get data transformation config. Let me try to see if everything is okay. So here we need to, now in the config part, component config, we need to import. So here, as you can see, path. So we need to also import path. So we just import it as the first. No, I can just say from pathlib. From pathlib. import path. Then we also need to do import the data transformation config. So this one we are going to so here you can just copy this. Make sure we are just insert brackets, and then this one can just save it here. So when you save that, then you can see the error is not showing. Error is not showing under the configuration. So data ingestion config, data validation config, then get data transformation config. The rest will be about model trainer. So configuration done. Configuration done. The configuration, we go to component. So our component is the component number 3, data transformation. So data transformation, we just import the entire class for data transformation minus the pipeline. So you can just copy this data transformation, give some space, and then you can just copy that. So after this, we need to import the necessary libraries. So import OS, and so most of these things, instead of typing, you can just import them. I think this one, all of this is necessary. So import transformation, then can import this. So data transformation config, we need to import entity from entity. So again, you can say from src dot electricity bill dot entity dot configuration entity import data transformation config. Data transformation config. So we are done with that. Logging. So we need to import logging. So from src dot electricity bill import logging. Yeah, supposed to be logging. So import logging PD. So we need to import pandas. So from import pandas as PD. Import OS pandas as PD. So that's okay. We also need to import joblib. Save objects. Need to import the save object and the joblib. So import PD. So import joblib. So joblib plain test. That's okay. We also need to, from commons, need to import save object. So I'll just include it with these ones. So from src electricity bill dot entity dot it's supposed to be utils. Dot commons. We're going to import save object. That's it. Let's see if we have any other thing that is missing. Something that is missing will just show itself. Data transformation config object. So data object standard scalar, one-hot encoder, simple imputer, pipeline, column transformer, train test split, joblib, PD, OS. Yeah, I think everything is okay. So after the components, we go to the pipeline. So we are done with the components. We go to pipeline. So our pipeline, yeah, this one is the pipeline. So we can just rename this. So rename pip03 data transformation.py. So data transformation, don't need this one. We are done. We are done. So data transformation as a pipeline. So we are going to design the pipeline for that. So for the pipeline data validation, you can just copy this first. Data pipeline. We need the configuration manager. Instead of data validation, we need data transformation. So that is C data transformation, import data transformation. Data transformation. We also need logging. We also need import OS. We also import from pathlib. Import path. So those are the required stuff. So we can just copy this, then we'll just make some changes. So this one, so our pipeline name is data transformation pipeline. So data validation, data transformation pipeline. So data transformation pipeline. So again, configuration manager. So the pipeline. So here we are going to try out something different. So class data transformation dev init pass. So main dev self main. So here, let's do away with this. We're going to try something else here. So dev. So try. So with open brackets path. So our path is the from our validation status. So artifacts data validation status.txt. So we are going to open this file, the read by as f, so that if this is true, then this process should continue. Read, then split this, then -1. So you can say that if status is said true, and say that were we getting true? Let's see. Status, if status is true, we're going to read that, and then supposed to be like this. True, then the data validation pipeline has been executed, and that is okay. So after this, we can log some info. If status equals to be true, then logging the data validation pipeline has been executed. Then we can start some logging.info. Then here we can state now we can start this process. Let's say so what's this one? Then we can say pipeline name. So we can say pipeline name started. Then can do this, say hash. Then you can say if the status is true. No, something I'm missing here. If it is true, it's supposed to do something. Let's see, let me try to here. Then and say else. We're going to place exception. The data schema is invalid. Okay, so then the rest of this code should be inside here. So you can start so you can copy this. So data transformation dot save data professor. And also again use this. Nope. And slash this string data test data path, string data path test data path, then slash right, and again we can slash, you can slash like this. It's you can just say store data. So this is the so need the else raise this, then we need the except blocker. Block except block print e exception as e. So else then we can also say login info data transformation. We need this one. So data transformation pipeline, close this gap. So let me try to explain what we are doing here so that we are in sync. Okay. So with the data transformation pipeline, I'm relying on the data validation status to ensure that we are able to execute this pipeline. So if you're going to execute this pipeline, you first need to ensure that our validation status is true, something like this. So we need to ensure that our validation status is true before we can even start so we need to ensure we are relying on the data validation before we can run our data transformation pipeline. So we need to ensure that our data validation status is okay. So that it means if the data transformation status is true, then we can raise a message to say that the data validation pipeline has already been executed successfully. So then from this, we can now start executing the transformation pipeline. So we log a message, transformation data transformation pipeline started. Then we config data transformation, this and this. Then now we can store our data. Then after this, if this is not true, else we're going to raise an exception, and this exception will be that our data schema is invalid. So we need to correct that if that is the case. Then logging information pipeline terminated successfully. Okay, so that's it. Then from here we can use so data transformation pipeline. Just going to copy this data transformation pipeline, terminated successfully. So pipeline started, transformation successfully. So do I need this one here really? I don't think I need this. This is supposed to be in the main.py if I'm not wrong. So print as E. So this is a data transformation pipeline, data validation pipeline. So for the data transformation pipeline, I don't think I need the if else here. Okay. So I'll just go to the data transformation. So to the main.py. So main.py. And in the main.py, I can just copy this. So component name data transformation component. So data transformation component if this and this started. So pipeline data validation pipeline ingestion.main logging this information, this. So I think this one is okay. Let's run the main.py to see if we are going to get our data. So Python main.py. Let's see. Python main.py. So oops, so this and this are just the same thing. It's something I haven't done. So we need to data transformation. We need the data transformation pipeline. So the main.py is supposed to be data transformation pipeline. Then we need to import that here. So from src.electricitybill.pipelines pip number 3, pipeline number 3. We're going to import data validation data transformation pipeline. So this one here, this. So let's run this again. Let's see. Yeah, I think it's now running okay. Data transformation has not saved that. Either way, data transformation object has no attribute save date. Either way, no problem with that. So data transformation component terminated successfully. So we are able to execute that. So okay, so I think that's it. So after this, we need to push. So git add dot git status. So these are the files. Git commit -m. So we can say data transformation. Data transformation complete. Data transformation complete. Okay, so and then after this, git push -u origin to main. Yeah, I think we're okay with that. So let's try to run this. So data transformation complete. Yeah, that's okay. This one is okay also. So if you check the logs, check the logs. The logs again, you can see now. See how your logs are looking okay. Okay, so this is how we do this. Okay, so that's it. So that's it for data transformation. So now you can see how you can do data transformation. So there are numerous ways that you can use in the data transformation. Of course, here we just used simple imputer and all that. So you can, for example, if you want to remove outliers. Okay, so before we do this, you can create another object, another method here to remove outliers. Remove your outliers, then separate the columns into this and this. Then you can also do the transformation. If your columns does, for example, our column, this one, sometimes your column does not contain categorical values. Then you don't need the categorical transformer. So you can just create this so that in case you need to scale your data, if now your data changes, now it reaches a point you need now to use your data might change, and in the process you might get categorical values. So you can just come at this section and just change this section here. Okay. So this one, another thing about data removing outliers. Another thing is about let's say if you want to use the PCA again, this is the section where you need to introduce that the PCA. So I think PCA will, if you're going to use the PCA, you're going to use that on the training set data. So I think the most appropriate section will be after you're doing the train test split, before applying this processor object to the training data, you need to pass that data through principal component, or you can split the data, apply the principal component. Yeah, So it all depends. It all depends. If you need things like the smote, if you want to, you have class imbalance, then this is the point where you need to achieve that. Okay. So I think we have tackled a lot of things under this. We have done a lot of we have done a lot of things under data transformation. This is one way you can do this. You can add other transformation steps. It all depends on you. Or if you don't want to use the column transformer, you can use the make column transformer. So it all depends with what you want to do or with the steps that you need to achieve for data transformation. All in all, that's all for today. Once again, I'm very thankful for your time. Please consider subscribing to the channel. Hit that uh, hit that notification bell so that you never miss any of our video updates. Also, please like this video and share with your friends. So until next time, I'll see you in the next video. So before we close, the next video will be about a model trainer. So I will separate model trainer and model evaluation. Then I think the other one will be making using Flask to build an interface front, getting the name. Anyway, that's it. See you in the next one. Bye bye.